Okay, so let's continue for the discussion for the questions. So this is the diagram that shows the apparatus setup for the experiment to determine the rate of reaction. Okay, so we know that this is actually related to the chapter, which is the rate of reaction. So we have the apparatus setup, which is, okay, we have this conical flask, and then we have a A4 paper with a X mark. And then inside the conical flask, we have the sodium thiosulfate solution with the hydrochloric acid. So which of the following methods is the most suitable to determine the rate of reaction? So basically you need to know what is the reaction between the sodium thiosulfate solution and the hydrochloric acid. So the product of this reaction is actually a gas, okay? So it means that it will release the gas until you cannot observe this X mark. Okay, so the answer would be D, which is record the time until the X mark disappears from the view. Okay, so next for the question. This is the diagram that shows two products made out of the composite material. So we are going to identify the correct matches of the composite material. So the matrix sustain is actually like the inner part of it. So what is the characteristic that we want is, we want it to have low tensile strength, okay, low stretching strength. And then the strengthening sustain, it means that we need to enforce the strength, right? So this sustain, this material must be strong, so it needs to be the high stretching strength. So for the next question, okay, diagram 9 shows the apparatus set up to investigate a redox reaction. So we have the copper straight, and then we have the silver nitrate solution, which is AgNO3, and we have the copper. So this is basically related to the displacement reaction. So based on the standard electrode potential, so the copper is actually more reactive than the silver, right? Okay, we want to find what is correct about the reaction. So copper is actually able to displace the silver out of its salt solution. Okay, so copper is actually going to release 2 electrons, and then the silver nitrate ion will get 1 electron to form the silver ion. So when the copper release the 2 electrons, so it is a oxidation. So automatically this silver nitrate is actually, or this silver ion is undergo the reduction process. So A is correct. And then B is also correct, because the copper released electron. Copper atom released the electron, and then it formed the copper 2 ion. Lastly, it will react with the this copper ion is able to displace the silver ion from its salt solution and become the copper nitrate solution. So the oxidation number for the copper decreases from positive 2 to 0 is not correct. It should be increased from 0 to positive 2, okay? It should be increased from 0 to positive 2. Okay. So for the next question, this chemical equation represents a cracking process. What is the homology series of the compound Y? So we have this alkane. The reason why I said this C7H16 is an alkane is because it fulfills the general formula for the alkane. So let's say we put C7 in, we put the N as the 7, and then we will get H16. And then basically, if you want to know what is the homologous series of the compound Y, or basically just we want to find what is Y, we just do the mathematical correction. So what will be our answer is actually C7H16. You minus it with H5, H12, and then you will get C2H4. Okay, so let's see what homologous series will have this kind of chemical formula, or even you can draw it out. So this will be our answer, right? This structural formula is the same as the C2H4 here. So it has a double bond. It means that it is a alkene. Okay, so basically cracking process is just like you have a long string, and then you cut it. You cut this long string into several parts, maybe A, B, C, and D. So when you add this A, B, C, D together, you will get the complete string. This is just the basic or example for how the cracking process is going on. Okay. So for the next question, so we have this nuclear number of atom of element W. The nuclear number of atom W is 23, and the atom W has 12 neutrons. Which of the following elements will have the same chemical properties as W? Okay, so the proton number of the W is equals to the number of nucleons, which is 23 minus 12, then we will get 11 proton number, isn't it? Okay, so we know that this proton number is actually same as the number of electrons. So in this case, the W has 11 protons, so it also have 11 electrons. So if you want to find whether one element, whether it has the same chemical properties as another element, we need to check for the valence electron. Why we need to check for the valence electron is because for the elements that are located in the same group, they always show the similar chemical properties, isn't it? The reason why they show the similar chemical properties is because they have the same number of electrons. So let's say in group 1, they all have the same number of valence electron, which is 1. So they will also share the similar chemical properties. Means that they can react with if a substance, let's say A, can react with the oxygen, so B also can react with the oxygen. If A can dissolve in the water, so B also can dissolve in the water, and then same goes to C and D. Okay, so now we have these. Let's write the electron arrangement for W first. So it is equal to 2.8.1, right? So when we add these 2, 8 and 1 together, we will get 11. So if you so we can actually know that from this valence electron, it is actually a group 1 element. So the answer would be potassium. Yeah. Even if you want to write it out, also can. Okay, we will also get the same one as this, and then this will be your answer. And then for carbon, we will get 2.4, oxygen 2.6, magnesium 2.8.2. Okay, so let's continue for the next question. Okay, we are given the energy level diagrams. We have the reaction 1 and reaction 2. We have the reaction 1 and the reaction 2. Okay, so one reaction we have this reactant going down. So this is the exothermic reaction. So you need to memorize for the energy level diagram for the exothermic reaction and the endothermic reaction. So for this, when the arrow is going up, so it will be the endothermic reaction. So okay, we are going to find what is the correct match for the reaction 1 and 2. Okay. For A, heat energy absorbed during the bond formation is lower. No, it should be higher. Okay. And then for reaction 2, the surrounding temperature should be decreased. The reason why it is an endothermic reaction is because it absorbs the heat from the surrounding. So oppositely, the exothermic reaction will be release heat to the surrounding. So the surrounding temperature for reaction 1 should be increased. So C, the heat energy released during the bond formation in the product is higher. And then the energy content is, for reaction 2, the energy content of the reactant is lower than the product. Okay, C is correct. Okay, so let's go through another question. So this is the questions that shows the structural formula of a rubber. And then we have the sulfur crosslink. It means that this rubber is actually the vulcanized rubber. Means that when we are making this kind of rubber, we add the sulfur into it. We add sulfur inside. So the reason why we add the sulfur inside is so that it has a high resistance towards the heat, because it can provide stronger, because this sulfur crossing is like provide stronger strength. Okay, so A is not correct because for this kind of rubber, when we add the sulfur into it, it will not get oxidized easily. Okay, so for question 30, this is a coconut. Okay, we have the coconut oil, which is a saturated fat. Which of the following composition is the correct about the percentage of the fatty acid in the coconut oil? So okay, so in this coconut oil, we have the lauric acid, linoleic acid, and oleic acid, and we just need to know whether it is high or low. So maybe you need to refer back to your textbook or any reference book. This kind of question is actually very rare, so maybe they will not like really come out in the exam, because like it needs you to memorize it. So the answer will be C, which is in this coconut oil we have the high lauric acid, low linoleic acid, and low oleic acid. So I think we will discuss the question until here first, and we will continue in the next video.